There are at least one set of connection on each oscilloscope for connecting the external signal to be displayed. Modern scopes can display two or more signals at a time and therefore would have a set of jack for each signal to be displayed. Since our scope is a dual trace scope, there are two. Those are sometimes called Y inputs. There are several controls on the scope. They include the vertical grid or scale control, volts over division, vertical position control, the horizontal scale control, time base, intensity control, trigger level, trigger source, and etc. There are vertical control for each Y input supported by the scope. Setting the time base to 200 milliseconds over division times 10 division is equals to 2 seconds will yield a display of 2 cycles. Therefore, increasing the time base will display more cycles of a periodic signal. Increasing too much will clutter the display. Conversely, reducing the time base, fewer cycles will be displayed. In the following figure, the time base is set to 50 milliseconds over division and 1/2 of a cycle is displayed. Reducing is too much may display a useless fragment of a cycle. As stated previously, increasing the time base further will display more cycles. However, to display one cycle of the 2 Hz sine wave, the time base needs to be reduced to 50 milliseconds over division. Since the inverse of the frequency 2 Hz equals 0.5 seconds is the signal period, and since our scope has 10 divisions, we have 50 milliseconds. Therefore, knowing the approximate maximum frequency of the input signal is the guiding factor for choosing an appropriate value for the time base. Recall that the inverse of the maximum frequency of a periodic signal will yield the time period of one cycle. Therefore, the time base should be calculated by taking the period of the signal and dividing it by the number of horizontal x-axis divisions times the desired number of cycles to be displayed.